Concept of J operator. What's the purpose of J operator here is to add one real number and one imaginary number. Otherwise, to add two quantities which are differ with respect to time or phase variation. In that case, we use J operator, nothing but vector sum. J operator. So, mathematicians they will physicians they will represent to represent a complex number, imaginary number. They will use word I operator. But engineers, electrical engineers, we are going to representing I for current. That's why in place of I, we are going to operating J. J square is nothing but minus J, minus 1. So J is equal to root of minus 1. Just few we have to remember. 1 by J is nothing but what? Minus J. If you want to multiply numerator denominator with J, you can get minus J. J cube is equal to also minus J. Right? Minus J. J operator can be used to indicate lead or lag currents or voltages. Lead or lag current voltages. And complex number represented in rectangular form as C is equal to A plus JB. In polar form, C at an angle pi. So if rectangular form is given, how to convert polar? We know. This rectangle is given as 3 plus J4. How you can convert into polar form, phasor form. C is equal to under root A square plus B square. And pi is nothing but tan inverse of B by A, imaginary by real. Similarly, if any phasor form given, if we want to convert into rectangular, we use formulas as A is equal to C cos pi, B is equal to C sin phi, B is equal to C sin phi. So some example problems also I was specified here for practice, for remembrance about S plane. Remember, S plane real values always we define on x-axis, imaginary values we define on y-axis. And phi is measured in always in counterclockwise direction. So real axis if it is 0 means counterclockwise, y-axis 90. Next opposite to in phase opposition to real axis 180, and in phase opposition to imaginary or y-axis imaginary minus 270 degrees and 360. If you taken in clockwise direction, minus 90, minus 780, minus 270, like that we specify. It's about J operator. Now with this knowledge, we will see about combinational passive elements through AC source. Means first let us assume RL series network with the AC voltage source. Now all are connected in series. Series current is same. So here see resistance. Now if current is flowing through the resistor according to Ohm's law, voltage will exist similarly across inductor also. Now voltage across resistor is time invariant, voltage across inductor is time variant. Why? Because it's a frequency associator. Why? Because omega is equal to 2 pi fl if I define. So the sum of these two passive elements is vector sum I have to use, means J operator. So if we apply KVL to this loop, voltage giving is source, taking our resistor inductor. So we will get supply voltage equal to vector sum of VR plus VL. Vector sum of VR plus VL. So which is equal to, if I apply Ohm's law, VR is equal to I into R plus voltage across inductor is equal to I into XL. I into XL. Current is same. If we take current as common, we can write expression as V is equal to I into R plus J XL. Because we use J operator. Why? Because it's one is time invariant and the is time invariant. This I can write as R plus JXL. I can assume this as word Z. Z is called impedance. So this magnitude we can calculate by using formula as root of R square plus XL square. Root of R square plus XL square. If you want to phase angle, pi is equal to tan inverse of XL by R. means that rectangular form we can written into polar, nothing but Z. So impedance. Now see, Z is equal to R plus JXL. With this, if we draw impedance triangle, so R on x-axis, XL on y-axis, positive. So because plus J represented here. So the vector sum of those two, nothing but Z. So from this, we can define cos pi as cos pi is equal to R by Z power factor. See, up to now power factor is nothing but we studied as the phase cosine of the phase angle between phase values of voltages and current. And another expression, another formula we will calculate by using as cos pi is equal to R by Z. This triangle is called impedance triangle or phase triangle. Now we have to calculate power. Useful power is nothing but average power. So instantaneous power is nothing but instantaneous value of voltage and instantaneous value of current. Now the network is here. The network is RL network. If we draw the vector diagram here by taking here series means what? Voltage division takes place. That's why current I am going to taking as a common here. If I took current there, so because of resistor, voltage will exist in phase with the current. So VR is represented. Next, voltage across inductor, it won't exist immediately, right? So inductor opposes changes in current. That's why voltage leads current. So leading means we have to take counterclockwise direction. That's why voltage across inductor is represented in exactly y-axis, positive. The vector sum of those two is nothing but V. Now supply voltage V. Now if you see the phase difference between supply voltage and supply current, we can say the nature of network is lagging. Why? Because if you take an voltage as a reference, if you want to move to current, we are going to counterclockwise direction. Means we can say current lags voltage by an angle 90 degrees. Otherwise, if you take a reference as current, if you want to meet voltage vector, we have to move clockwise direction. You can say voltage leads current by an angle pi. Means you can say here the nature of the network is lagging. The nature of the network is lagging. Now this phase angle pi depends on magnitudes of VR and resistor and inductor. If resistor magnitude is more, phase angle moves towards VR vector. If inductance magnitude is more, that vector moves towards VL vector. Supply voltage vector moves towards VL vector. Now average power we have to calculate. So if we want to calculate average power per cycle, average power Pm Im by 2 into 2 sin omega t into sin omega t minus pi. After that, by simplifying, if we applied limits, means we are going to calculating per cycles, means 0 to pi. Then we will get expression per power as Vrms Irms into cos phi. Vrms Irms into cos phi. This is about AC through series RL network. Next, AC through series RC network. Here also, if we taken one RC series network, if we connected a voltage source, if current is flowing, voltage exists across resistor and voltage will exist across the capacitor. Now the voltage, supply voltage V is equal to vector sum of VR and VL, VR and VC here, capacitor. So which is equal to I into R, I into XC. Voltage across capacitor is I into XC. X is nothing but what? 1 by 2 pi FC. Frequency is existing in denominator. Means J we have to specify with 1 by 1 by J. 1 by J is nothing but minus J. 1 by J is nothing but minus J. That's why this expression becomes I into R minus J into I into XC. If we take an I as common, we can get expression as R minus JXC. R minus JXC. This we can write as V is equal to I into Z. Z is nothing but R minus JXC. Means XC is existing in down. So if we taken current as reference, VR is always in phase. Then VR is Negative j means at 270 degrees positive we have to represent is nothing but minus 90. So downward to y-axis VL, VC, sorry, not VL, VC. Then the vector sum of those two is nothing but supply voltage V. Now here we have to know the nature of the network. See, supply voltage, supply current. From the current to meet V, we have to move clockwise direction. Means we can say here V lags I by an angle 90 degrees. V lags voltage by an angle 90 degrees. Otherwise, if you take V as reference, if you want to meet to I, we have to move counterclockwise direction. Means with this you can say I leads V by an angle 90 degrees. I leads V by an angle 90 degrees. Leading is nothing but capacitive. With this we can say the nature of the network is capacitive, because here current is leading V. Now here also, if you want to calculate Z magnitude, Z is equal to root of R square plus XC square. Pi is equal to tan inverse of XC by R, tan inverse of XC by R. Instantaneous value of power is equal to instantaneous value of voltage and instantaneous value of current, product of voltage and current. So V is equal to Vm sin omega t, I is nothing but Im sin omega t plus pi. Now if we calculate average value power per cycle, then we can get expression per power as Vrms into Irms into cos phi. Vrms into Irms into cos phi. This is about series RC network. In next case, AC through series RLC network. AC through series RLC network. Let us assume a network with a series combination of RLC excited with AC supply. Then if we apply KVL, Kirchhoff's voltage law, we will get expression for as we are here giving energy element is supply voltage, remaining 3 are taking energy or power. So Qing V is equal to vector sum of VR, VL and VC. VR and VC. In both the cases, inductor and capacitor omega angular velocity is omega. That's why we can say those two are having same frequency. Why? Because those are existing because of supply frequency. That's why both are in phase opposition. So this expression we can write as V is equal to I into R plus JXL minus JXC. This expression we can write as V is equal to I into R plus J into XL minus XC. This, if we assumed V is equal to I into Z, where Z is equal to R plus J into XL minus XC. Now we have to know the nature of the network. Here, while defining the nature of the network, we'll see with the three cases. If in the first case, if I assumed XL is more than XC, inductive reactance is more than capacitive reactance. If inductive reactance is more than capacitive reactance, where more because current flowing there is same. So if XL magnitude is more than XC, the voltage across the inductor is more than voltage across capacitor. Then we can say inductor magnitude is dominating. If inductor magnitude is dominating in that expression, you can say the nature of the network here is lagging. Otherwise, if we draw the vector diagram also, here, so if I taken current as a reference, VR will exist in phase with the current, VL will exist in positive J, VC will exist in negative J, downward of y-axis. The magnitude is where VL is more, so VL minus VC will get VL is dominating, means near to in the positive J operator y-axis, the resultant voltage will exist. Then the vector sum of those two will get supply voltage as leads. Supply voltage leads means current lags. then you can say the nature of the network in this case is lagging. Suppose if I assumed XC is more than XL, X is more than XL, then we can say the nature of the network is leading. Why? Because the resultant of VC and VL moves towards VC. If towards VC means VC lags current or I leads, means the nature of the network is leading. Suppose if I assumed XL magnitude or XC both are equal, then the resultant of those two becomes 0. Then the nature of the network is resistive. Why? Because supply voltage is nothing but voltage across resistor and current both are in phase. If both are in phase means we can say it is a pure resistive network. The phase angle between those two is 0 degrees. Phase angle between those two is 0 degrees. In this condition we can say the network is in resonance condition. Whenever inductive and capacitive effects are equal and opposite, then the resultant impedance is equal to resistance magnitude. Means we can say the nature of the network is resistive. The nature of the network is resistive. So under resonance condition, phase angle pi is equal to 0 degrees. Then the power factor is unity. Cos 0 is 1, unity. Next, parallel RL network. If you take an RL parallel network, if we exert it with a voltage source, then here voltage across all the elements are same. Here current division will take place. Current division will take place. So we have to apply here KCL. So according to KCL, supply current is equal to vector sum of IR and IL. Vector sum of IR and IL. Here IR is nothing but V by R. IL is nothing but V by XL. Then supply current is equal to V into 1 by R plus minus 1 by JXL. Why? Because XL is equal to 2 pi FL. Frequency existing in denominator means minus J. Frequency existing in numerator means frequency existing numerator means plus J we use. So here 1 by R we are going to assume as one term, the term named as conductance, and 1 by XL we assume here as inductive susceptance, denoted by letter B suffix L, inductive susceptance. So I is equal to formula according to Ohm's law in each circuit V by Z, where Z is nothing, 1 by Z is nothing but what? G minus JB. So 1 by Z we are going to assuming as admittance, denoted by letter Y, is equal to G minus JB, G minus JBL, G minus JBL. Units are mhos. 1 by resistance, nothing but amps per volts. Simply can call those as mhos. So admittance here is equal to G minus JB. Now the magnitude is nothing but root of G square plus BL square. B square, G square plus BL square. If you draw the vector diagram, you can get why negative sign is going to nullify. So phase angle pi is equal to minus BL by G, minus BL by G. If you want to draw the vector diagram, so here in parallel which quantity is same? Voltage. That's why you take voltage as a reference. If you take a supply voltage as a reference, current because of resistor will force in phase with that, and current will force because of inductor is what? Lags 90 degrees. Then the vector sum of those two is nothing but supply current. Now supply current is lagging supply voltage by some angle pi. Then we can say the nature of the network is lagging. See the vector diagram here. The nature of the network is lagging here. Nature of network is inductive. You can say simply inductive. Next, parallel RC network. Same here also. We applied excitation of AC signal to the parallel RC combination. Then supply current is equal to IR plus IC. IR is nothing but V by R. IX is nothing but what? V by XC. X is nothing but 1 by 2 pi FC. So 1 by F is nothing but frequency is coming in numerator. So we represent with the letter J. This we can write as I is equal to V into G plus JBC. BC is called capacitive susceptance. Remember, capacitive susceptance in parallel networks. So here impedance Z is equal to 1 by G plus JB. 1 by G plus JB. Now admittance is equal to 1 by Z, which is equal to G plus JB. G plus JB or JBC. Y is equal to root of G square plus B square, and phase angle phi is equal to tan inverse of BC by G. Now to know the nature of the network, if we draw the vector diagram, here also same equal quantities voltage. IR will exist in phase with V, and IC will exist. Current leads IC will exist in phase with 90 in y axis IC. Then the vector sum of the voltage is nothing but supply current. Now here current is leading V by an angle phi, means we can say the nature of the network is capacitive. The nature of the network is capacitive. Now parallel RLC network. Parallel RLC network. See, parallel combination of resistor, inductor, capacitor connected with supply voltage source. Then after that, if we apply KCL, we get a supply current is equal to vector sum of IR, IL, IC. If we apply Ohm's law, we will get expression as I is equal to 1 by R plus J into minus 1 by XL plus 1 by XC. So 1 by XL is nothing but what? BL, inductive susceptance. 1 by XC, capacitive susceptance. So with this we can write I by V is equal to G plus J into minus BL plus BC. So 1 by Z is nothing but what? So Y is equal to G plus J into BC minus BL. BC minus BL. Now if BL is more than BC, if BL is more than BC, then IL is more than IC. Current flowing in inductor is more, then we can say the nature of the network is inductive. If you want, you can draw the vector diagram. Supply voltage V, IR is always in phase with V, so IR, and IL is always lags V, so downward, IC always above. The resultant we assumed here as BL is more than BC. If BL is more than BC means XL is less than XC. If less than means resistive nature. XL is less than, lesser value means more current will flow. So inductor behavior is strong here. More current will flow in the inductor. Then the vector moves towards IL. Resultant current moves towards IL. This you can say the nature of the network is lagging. Hence in parallel resonance condition, to define the nature of the network, we are going to assume three cases as like in series resonance condition. The next condition, if we assumed BC is more than BL, then IC is more than IL. If IC is more than IL means it vector moves towards IC. Means we can say the nature of the network is capacitive. Why? Because I leads V by some angle.